Hi guys, welcome back. So we have done some little bit of improvements from our previous circuit. So we said that the alarm circuit will have two sets. So right here we have a CD4029 and also here we have a CD4029. So this CD4029 counts in binary. Also this one counts in binary, but this one in the clock is driven by the seconds counter. So the seconds counter drives this. So this is just a representation in the real. Once I connect it to this one, then the white jumper, which is this one, which is the clock, will be gotten from the real seconds counter that we have on the real clock. This is just a representation to show you how it counts in binary. Right here we also have a CD4029 which is counting in binary, but here the clock is driven by a push button called the set push button. So this side is for the user, so the user can set the value that he or she wants. Then if he or she has made a mistake, then press reset until it goes off like that, and they can set again. Yes, like that. So this is a part of the user, and once they have set the value that they want, or they have reset and set again the value that they want, and this value is taken to a time matcher. So the time matcher compares the value from the clock and from the user, and if both of them are true, then it's going to give an output to the siren module. So we still have another circuit called the time matcher, which is going to compare the values that we have from the user and that of the clock, and if both of them are true, then it's going to give an output to trigger the siren module, meaning that the time has been reached. So I really hope that you understood last time why we changed our IC from using a CD4017 to a CD4029. It's because right now you can see we are displaying numbers from 0 all the way to 15 using only 4 LEDs. But for a decade counter, displaying from 0 all the way to 10, it requires 10 LEDs. So that is a little bit of hectic, and the amount of circuitry needed just to compare those values a lot, because we need 10 AND gates and all those 10 input OR gates, or very many things. So the advantage of using a CD4029 is because you can just display all those using only 4 LEDs. So 4 LEDs means that you're going to need only 4 XOR gates and 4 input AND gate, because you see those are very few as compared to using a CD401, CD4017. So right here, which is the set push button, I had a problem with it. The set push button, as you can see, it's not constant. Sometimes just jumps, you can see it just goes. It's not constant. That's why I tried using a port meter and a capacitor just to filter out the noises from the push button, because it's not constant, it's not stable. That's the right word. It's not stable. So what I decided I'm going to do next time, I'm going to put a display. So these are for CD4029. I'm going to put these outputs that you're seeing in binary in a 4511 CD4511, which is going to drive a common anode. You remember that common anode that I was using last time? So this is the right IC that I needed to drive it. So since I have it, so I'm going to drive it, and once you have set your value, it's going to be displayed in a 7-segment display for you to see what you are pressing, because not all people know about binary. So yes, so we want to display this in a much simpler form in which humans can understand. So that's why I'm going to put a CD4511 to drive a common anode for us to see what we are pressing. Yes, and once you've made a mistake, as usual, just press reset and it goes all the way to blank. So that's what I wanted you to see today, and hope we are still moving on together. So if you have any suggestions, any questions, you can just ask in the comment section, and I'll be glad to answer you. So thank you very much guys for your time, and thank you for watching this video. Please subscribe and follow Tronic Energy, and hope to see you next time. Goodbye.